Good afternoon, all of you. In today's lecture, we will study about PWM converter. As you know, converter is two types: one is rectifier, other is inverter. In the rectifier, we convert AC voltage into DC voltage. In the inverter, we convert AC voltage into DC voltage into AC voltage. Inside the rectifier, there is a consist of thyristor circuit, yeah, the half wave rectifier, a full wave rectifier to convert AC into DC. Here it is consist of any inverter circuit, just like voltage source inverter and current source inverter, to convert DC to AC voltage. Whether the converter serves as an inverter or rectifier, power flow in the converter circuit is bidirectional. Power can flow from the DC side to AC side or vice versa. The, the presentation focus on the carrier based sinusoidal PWM technique of the converter. How an inverter PWM inverter works DC voltage to AC voltage. This is the circuit diagram of the voltage source inverter. These consist of voltage source inverter and DC voltage. How DC voltage can be converted to AC voltage, we can see from here. There two level of the PSC. Circuit diagram we can see. Circuit diagram has two level voltage source converter. The converter composed of 6 switches S1 to S6 with the anti-parallel freewheeling diode. You can see the anti-parallel freewheeling diode and consists of switches. Switches can be IGBT, MOSFET depending on the power rating of the converter. Sinusoidal BMA, these are the voltage of the input voltage BA, BB, BE, BC are the three-phase sinusoidal modulating waveform. These are the modulating signal, and BCC a carrier signal present. The fundamental frequency component in the inverter output voltage can be controlled by amplifiers by amplitude modulation index. The modulation index is nothing but message modulating signal amplitude upon carrier signal amplitude. Frequency of modulation index is carrier frequency upon message signal frequency. These are the circuit sinusoidal PWM. The BC link capacitor. These are the BSI voltage source inverter, DC link capacitor, the DC link capacitor, and DC source supply, and these are switches, 6 switches. These are the final waveform of these are the sinusoidal PWM. Whenever voltage across any phase is modulating signal greater than the carrier signal amplitude, when amplitude of the message signal greater than amplitude of the carrier wave, then at that time that voltage across that phase present. That similarly under upper switch S1 is inverter legs turn on and result the voltage BAN in the equal to BDC. Whenever message modulating signal amplitude greater than the carrier signal amplitude, there will be in that phase the voltage will be present in that switch. Similarly on this waveform you can see at that time the DC voltage present. The waveform of the two level therefore inverted refeed to two level inverter. We can feed it to two level inverter. The inverter line of the voltage can be VAN minus BBN. Phase AF and phase BB subtract, we will get finally sinusoidal waveform here like this. Sinusoidal waveform. What is that time? That time to avoid the possible short circuit upper lower device in the inverter legs should be implemented using both the switches must be turned off. The magnitude and frequency of fundamental component BAB can be independently controlled by EMA and FFM. The switching frequency of a active switch of two level inverter is equal to F. W is equal to F carrier into modulation index and message signal modulating frequency FM. The difference between the synchronous PWM and asynchronous PWM is the synchronous PWM carrier frequency is varied according to the modulating wave frequency. In this carrier frequency is varied according to modulating wave frequency. Can obtain desired number of pulse and the optimum pulse by varying the carrier frequency with the modulating frequency. Need digital circuit for the implementation. But in case of asynchronous PWM, carrier frequency is fixed and independent of the modulating wave frequency. Here carrier frequency cannot vary according to the message signal frequency. No control on the number of pulse, and so pulse width as a carrier frequency fix. But we cannot vary the pulse width of the signal. Easily implemented using analog circuits. These can be implemented with analog circuits. This is the most important part of this PWM. You can see wherever the message signal frequency amplitude greater than the carrier frequency, then the pulse are present, just like you can see whenever at this point you can see this is greater than to become the analog pulse like this. So similarly we can get here for all the three phases, of the switch, we can get voltage here. This is all about PWM. Any student face any difficulty, let me know. Mail me if you have any queries. Thank you.